Multimedia Apps Programming Series 11. Today we are going to talk about how to build your apps and put it all your back office to Google App Engine. Today's topic is Google App Engine, or GAE for short. What we are going to talk about is, on top of Google Cloud Platform, a lot of tools or platforms you can use from. So we'll talk about how to use App Engine and upload your completed final project apps to Google App Engine running in the cloud. So there are 3 topics we would like to cover for today. As we have already covered the broad range of services or tools provided by Google Cloud Platforms. So we'll recap and review some important services or platforms, tools provided by GCP or Google Cloud Platforms. That is the first topic we'd like to cover for today. Second is Google Cloud Data Store. That is the main databases or data store or database you can save all your apps users' data in cloud. So that is Google Cloud Data Store. It's like a hard disk. It's like data you can store. And another tools we have already introduced in this course, last week, that is Google Firebase. So you will get familiar with that and with some hands-on experience for today. So what is backend? Emily Lee, do you know what is backend? There are 2 ends. One is front end. It's like the user interface. It's front end, right? And what is back end? And how about Amy Chen? What is back end? There are 2 ends. One is app front end. It's like user interface running in your screen. And what is back end? Sorry? Firebase. Yeah, that's great. And another one, that is Firebase is back end. Correct? Any other? Do you know there are 2 engineer you can work with? One is back-end engineer. Another one is front-end engineer. If you would like to apply a job or your teams, suppose you are project manager, you are PM, right? You have to hire 2 types of engineer. One is front-end engineer. One is back-end engineer. Do you know what is the difference between front-end engineer and back-end engineer? No? For example, if you are writing HTML code, if you are writing CSS, cascading style sheet, if you are writing JavaScript for the display in the screen, that is, you are front-end designer or you are front-end engineer. Do you know what does that mean? Front-end is like you design a screen, you design user interface, you design the behavior of the appear in the web or in app, the user interface. However, that is for the front-end engineer. Right? Would you like to apply the job for front-end engineer? You prefer, right? Yeah. And how about Emily Ling? Would you prefer to be a front-end engineer? Yeah, you prefer, right? And how about the job to serve as a back-end engineer. Would you prefer? No. How about you? No. What's the job descriptions for back-end engineer? That is that you have to configure the app server. You have to configure the web server. You have to configure database server. You have to configure, design the network connections or infrastructures. That is back-end office. So you have to use some tools to design database server, app server, app, or you have to design the web server. So there is a difference, right? So at back-end, meaning that you have some front end. It's like the iOS, Android, and app. That is the front end. It's like the user interface. For example, you write your Swift code. Swift code is running on front-end devices. And how about app back-end? For back-end is that you use mobile apps back-end on Google Cloud, or if you are not running on Google Cloud, you can run it on AWS, Amazon Web Service, or you can run it on Microsoft Azure, or you can install a Linux and running Ubuntu and set up your Apache server and set up your MySQL database server on your own and run it on your lab or your dormitory or your house. So that is many process. Would you like to set up a Linux server and run an Apache server and MySQL server in your dormitory, in your room, or in your office? You prefer this one. Why? Why you would like to choose this solution? More convenient. Why? Why it is more convenient? You can use like Google Compute Engine or AWS EC2. It's a virtual machine running in the cloud. You don't need to host a physical server in your room. You have to plug the power, and it's noisy, right? And you have to take care of your machine, right? You prefer this one, right? Suppose you are CIO or you are project manager, you will do this decision. Nowadays, you are the PM, you are the CIO, you are the chief information officer. You would like to ask your engineer, buy a server hosted in your office, your company. This is hardware. And install software in your company. You prefer this one, this solution. Why? Suppose you are the owners of the coffee shop. You are the coffee shop owner. You own your coffee shop, right? And then you need to provide service to your customer. You would buy a physical computer to install Ubuntu, to install Apache server, to install MySQL server, and put it in the coffee shop, or put it in your house, in your room, your apartment. Or if you are not buying the hardware, install operating systems, install MySQL database server, where you can run your service. You need a web service, right? Your customers would like to access to the website, or app would like to connect to the somewhere, right? And what if you don't buy a hardware where you can use? which solution you can use. You are the PM. You can make a decision. Someone is working for you. You have to make a decision. Which solution you would suggest your engineer, the partners, the members, your team's members would like to work with you, and you have to make a decision. Which solutions you would choose? Use cloud, right? And which cloud? There are many cloud solutions. AWS EC2 or AWS Web Service or Microsoft Azure, Google Cloud. Which one we would prefer? Google Cloud, right? And which solution or which service you would choose? There are two main options. One is Google App Engine. One is Google Compute Engine. Which one you will use? Do you know what is, App Engine, right? We introduced last week. App Engine is a platform as a service. PaaS. You know what is PaaS? Platform as a service. Like Gmail is a PaaS. It's a platform as a service, right? Compute Engine is like a virtual machine. It is an infrastructure as a service. Do you know what is infrastructure as a service? IaaS. Do you know what is IaaS? We introduced this concept, important concept, last week. Emily, do you know what is IaaS? There's a platform as a service. There's software as a service. Right? Cloud service mainly divided into three categories. Right? For infrastructure as a service, it's like compute engine. Right? It's like AWS EC2. Do you know what is EC2? EC2. Have you heard of EC2? Emily, have you heard of EC2? It's like a virtual machine. You know what is virtual machine, right? Virtual machine. There is virtual machine provided by Google is Compute Engine. The service name is Compute Engine. From Amazon is EC2. That is very important for backend server design or cloud design. What is EC2? Let me tell you. What is EC2? EC2, sorry. Here is EC2. Emily, could you please explain EC2? This is EC2 then. You see, have you ever seen EC2 logo? AWS. If you are the PM, if you are the CIO, you have to know what is EC2. This is the fundamental service provided by AWS. Now, our Department of Information Management, Tampa University, our web service, our web server, our website is running on AWS. We set up an EC2 that is like a virtual machine, and we porting our traditional website, web pages in the cloud. That is EC2. EC2 is a virtual machine, right, running in AWS. So compute engine is like, it's another there is a service. So you have to pay as you go, right? It's like you are running your electricity. It's a pay as you go. Okay? Meaning that you have to pay for you running on the server. Okay? So that is a Google Cloud Engine, Google Cloud. There's Google Cloud and App Engine. Okay, and data store as well as Firebase. So that is your back-end office. So nowadays, I would not encourage you to buy a computer, a server, a black box server, and put it to your office, your company, your shops, and plug and running on your Linux, your MySQL server. So that is old-fashioned. You know what is old-fashioned? That is traditional way. Nowadays, please use modern cloud architectures. We have to go to the cloud, into the cloud. Please do not use the old-fashioned way. Oh, you buy the laptop and put it somewhere, and you have to manage that. And you have to open the license, and it is old-fashioned. It's not modern way. Okay, so that is App Engine, meaning that there are two ends. One is front end, meaning that iPhone, Android phone, web phone, that is front end, is the user interface. And for your data interactions would send it to the back-end office. Back-end office meaning that it's in the cloud or in server. So you connect the data or process to Google Cloud, that is at back-end. So at back-end, there are many solutions. You can use Microsoft Azure, you can use AWS, Google Cloud, or your old-fashioned way, hardware. Okay? So that is the back-end, all in the cloud. Is that a good solution? So do you think it's a good solution? Or you prefer buy a computer, buy a server, a black server, black one, and you put it in your dormitory or your room, and there's a noisy fan. Which one do you prefer? You prefer buy your own? Buy your hardware or in the server. Which one do you prefer? In the cloud or in server? In the cloud. Okay, yeah. So there are many solutions, and you can decide which one you prefer. And just think about it. The important keywords here while we're using cloud. There is a keyword called scalability. Do you know what is scalability? Scale. Do you know what is scalability? Or scale out, scale, at large scale. Do you know what is scale? Do you know what is scale? Every chain, do you know what is scale? Suppose you are running Airbnb, a service, Airbnb, right? And you, for the beginning, you have 100 users. But sometimes your user is 1 million users. You have to scale it out, meaning that suppose one server, you can serve 1,000 users, but suddenly your users is growing to 1 million. You have to scale out your capacity, right? Otherwise, you have to buy 100 server to serve 1 million users. Do you know what is that? Scale out. For example, what is scale out? Is that for the cloud, scale out is automatically. You don't need to worry about the capacity. You don't need to buy more hard disk. You don't need to buy more RAM. You don't need to buy more CPU to serve 1 million, 100 million users in the meantime. So this is automatic because you're using Google Cloud storage. This automatically scale out, right? For example, firstly, you have one server, but because it's virtual machine, it's automatically distributed to, for example, 20 server. So you can scale out. It's a scalability, right? Okay. So like enlarge your capacity. Do you know there is a Pokemon? Do you know what is Pokemon? This is Pokemon, right? There is an app called Pokemon. It's a version. Have you played this game? Have you? Okay. Do you know where is Pokemon running on? It's running on Google App Engine. GAE. It's running on there. You know Angry Bird, right? Angry Bird is running on GAE, Google App Engine. It's not running on their black box server on their office. And do you know Airbnb? Airbnb, the website and the app, back office, back end is running on Google App Engine. So Airbnb is running there, you know? Okay. So now you know where this server is. Alright. So that is, for example, you are running your Airbnb, you are running your Pokemon app, and the computing, the storage, the data is stored from Google App Engine and then stored in Google Cloud Data Store or Phonegap. So that is back-end office. So let's recap Google Cloud platforms. As we introduced you, they are App Engine, right? They are also Compute Engine. Compute Engine. And do you know what is the difference between Compute Engine and Google App Engine? We introduced you last week. Can you recall? Last week, 7 days ago. Or could you please explain to me what is Google App Engine? What is Google Compute Engine? For example, if you are using Google App Engine, do you need to install Linux first? No. Do you need to install MySQL first? Do you need to install Apache server first? No. Google App Engine is a service. You can just write your Python code or your Java code and run it there. That's it. That's Google App Engine. However, Google Compute Engine is a virtual machine. It's a virtual machine, meaning that you have configured ready CPU, RAM, and hard disk. Do you need to install operating system on virtual machine? On Google Compute Engine, do you need to install Linux first? Do you need to install? Yes, very good. Because that is a machine is an image. You can run an image there, so you can choose which operating system you would like to install, which Linux version, for example, CentOS or Ubuntu. Have you set up Ubuntu or CentOS on your own? Do you have this experience? And how about you? You can try for setting up a virtual machine and running anything. Do you know what is the process for installing Ubuntu or CentOS? Do you know it is a fun way to do this hands-on experience? You don't like it, right? Yes, so that is, you have to use App Engine. Meaning that if you choose Compute Engine, you have to install Ubuntu first. Alright? So, because use this, you have to configure all the things in the cloud. Right? So I highly recommend you use App Engine first. Okay? And then you can use Google Cloud Data Store and Google Cloud Endpoints. So it's a cloud. So what is this mobile app backend services? It's like these architectures. Emily Chen, could you please explain these architectures for us? In page 11, that is the most important architectures. For the standard architectures, we are running our mobile apps. Could you please explain this architectures? It is very important. Now I am the member. I'm a team member. You are the team leader. You are the project managers. Please explain what is the architectures we would like to design our final project app. Suppose I'm a team member. I'm now the freshman. I'm the first year's undergraduate students. I'm just graduated from high school. I'm now the first year in this university. You are our team leaders. And we would like to design our final project app and deploy to Google Cloud, or we can final project app will publish on Google Play and Apple's App Store. Could you tell us what is the architectures we would like to use like this? I'm now the first year undergraduate students. I just graduated from high school. Please explain what's your idea about designing a good cloud-based mobile app. Suppose you are teaching assistant. I'm the undergraduate student. Please tell me what is the architectures. Yes, yes. Yes, wow, very good. Wow, and then? Yes, very good. Okay, very good. Wow. Let's give Emily Chen a round of applause. Very good. You explained pretty well. And how about Emily Lin? Do you think it's a description for this architectures? Yeah. And can you explain more about this one? Could you tell me what is that engine? What is Google Cloud Data Store? This is Google Cloud Data Store. This is Google App Engine. Could you explain? you can write code. You can write your Python code, or you can write your Java code on Google App Engine, running on Google Engine for compute, right? For calculating something, right? Like you can write Python code, do anything, machine learning in the cloud, and use the cloud GPU, CPU, right? So for machine learning, model training or predictions, you can run your model prediction, write your code, Python code here. The Python code is not running here. It's not running here. It's the like APIs running here, right? So you can run your Python code and publish in App Engine, right? It's a server, it's a backend. And suppose the models, you have your Pico files or your H5 files, where you can store your H5 files. Do you know where you can store your files? For example, you have some CSV files, right? Big data, you have some CSV files. Where you can store CSV file, Pico files. Do you know what is Pico file? Do you know what is Pico file? In Python, it's a binary code. You have trained a model and set it as a model file, right? The model file is set as a Pico file or H5 files. HT, right? You know, is H5. Those files can set here. It's like putting your code running here, right? It's compute, and the compute is computing. It's not storage. For example, you have write your Java. Java is a programming, right? And Java cannot. It's not a RAM. It's not a hard disk. It's like a hard disk storage. It's like hard disk. So you can use this one. So now you know what tools or what service you can use, right? Is it clear for you? App Engine, Google Cloud, is it clear for you now? Okay, now, good, very good. So there's the mobile app backend services. Okay. All right, there are many solutions you can use. For example, you can use simply use Firebase, or you can use Google App Engine with standard environment or flexible environment in conjunction with Firebase. Or you can use Google Compute Engine with RESTful API to run in, like set it on your virtual machine. Okay. So for the Firebase, here is the Firebase architecture is the most simple way. And you can also use Google Cloud App Engine with standard environments and process the data and save it in Firebase. So that's a solution. Number two, we have introduced you last week. And also you can use the third solution called flexible environment and save it or synchronize the data in Firebase. And the fourth solution or the fourth architecture is that you can use Google Cloud endpoints with App Engine for standard environments with these as a mobile backend. Final solution is that you can use a powerful computing provided by Google Compute Engine that you can set up all the stuff. You can, for example, you can set up a Windows server running SQL server in Google Cloud. You have to use Compute Engine. For example, you set up your Windows server in here, and then you install an IIS server and running like SQL server here, and you can use framework. That is that you can choose this compute engine. Okay? So that is the mobile backend office. Alright. Now we have introduced you the architectures for mobile apps backend design. Next, I'd like to introduce you how to store your data and how to exchange data. Anyway, how to store your coffee shop customers' information and how to exchange the data from coffee shop owner and coffee shop customer. Exchange data. How can you exchange data and store data from your app? Coffee shop reservation app. Booking is not bookinghotel.com, it's booking coffee shop app. Where can you store? Where can you exchange your data? Name some of the solutions or the service. How are you? Here with me. It is very easy. We have introduced you two solutions. One is Firebase. One is Google Cloud Storage. Which one would you prefer? Can you store data in App Engine? Oh, yeah, correct. And if you like to store data, or you like to exchange data, which solution you will use? Firebase, very good. That is Firebase. For Firebase, there are many formats you can choose from. One is JSON file. Sylvia, could you please tell us what is JSON file? Good, very good. JSON file. Would you prefer JSON file or would you prefer TXT file or CSV file? Which one you prefer? CSV file, right? .txt file. .json file. Which one do you prefer? CSV file, because it really is pretty easy, right? And also, JSON file is very easy to read. It's like a standard database. It's a lightweight database stored in JSON file. It's a plain text. JSON file is a syntax for storing and exchanging data. Right? It's like name. Do you know what is XML? XML, you know what is XML, right? And what's the difference between XML and JSON? XML is like database, right? With some attributes like columns and its values with a very clear way to store it, right? However, JSON is a lightweight. For example, your app would like to exchange data. JSON file is the best solution for exchanging and storing the data for your mobile app design. Please do not use XML to exchange data, meaning that you don't need to transfer JSON files to another mobile app or to server, because JSON is lightweight. It's shorter, it's sweeter, it's short and sweet solution, because XML is too big. A lot of description, right? So here's JSON is an easy to use alternative to XML. So for example, here is a JSON files, right? And this is XML file. You have your coffee shop app customer, right? you would like to store the employees. For example, employee first name John, last name is John, last name is Don, first name Anna, Smith, Peter, Jones. So this is JSON files. Can you read these files? How many employees are there in this database? Three employees, right? And how many columns are there in this database? 2. What is the column name? First name and last name, very good. And what is the values of the names of the first name column? Very good. So that is JSON files, right? It's starting from curly braces and with its key column and value, its key value pair. What is key value pair? This is key. Key is first name and the value is John, right? This key value pair with this curly braces. For example, this is a list. A square bracket or bracket is a list. So the list is 1, 2, 3 with 3 array. And this array with like key value pair is like a dictionary. Key dictionary meaning that it's a key value. Okay? So it's key KV pair. This is JSON file. However, the same data we store in XML is looked like this. Emily, Chen, could you please tell us, is this a big files or is this a short files compared to JSON? This is bigger or this is smaller? It's bigger. Why? Why it's bigger? Yes. And Sylvia, could you tell us what are the reasons for XML is bigger than JSON? Why? Close tag. Yes, very good. Let's give Sylvia a round of applause. Very good. That's the point. It's here because for the first name for JSON is first name column key value. That's it. However, for XML file, you need an ending tag. Closing tag is slash first name. That is redundant, right? You need a pair, right? The tag for XML file is you need a pair. So if we remove this one, it's like this one. Okay, it's shorter. It's short and sweet for JSON file to display the same content, right? So this is XML file. This is an alternative JSON files. So in mobile app design, I highly recommend please use JSON. Why we are not using CSV file? Because you are hardly to identify what is Peter. Is Peter a company name or is it a first name, right? Or is this an address? So different. You need a key or a column name or variable name to identify what is this value is. What is the meaning of Peter? What is the meaning of John's? Is John's a first name or is John's a last name? So you have to identify these views, these data. Okay? So there is JSON and files. So compare this one. This is JSON file and this is XML files. So it is a comparison. So why we can store data, store in JSON file format. One, we can exchange data use JSON as an exchange data format to exchange different database. Is it clear for you? Alright, now we have to use API to transmit or transfer or exchange these JSON files by using API. Right? Okay. Bell is ringing. Let's take a 10 minutes break.